short week this week. You didn't know that. So pull out your sheets. We last time went through, I guess, just about all the basics for isoquants and isocosts, and I think it'll be helpful to just kind of jump into a problem and see what's going on. So let's start off with 6.1. We've got a short-run production function for a firm that produces pizzas. And what is the little bar above that? It says quantity is a function of K bar and L. Anybody know what that little bar over the variable means? It's fixed, yeah, so it does not change. So anytime you see that bar over it, it's fixed. And so in terms of economics, we're getting into a short run, long run type talk. So we're going to say that the size of the building is fixed or whatever. All right, so Q is the number of pizzas, K bar is the number of ovens, which is fixed at 3 in the short run, and labor is the number of workers employed. So write an equation for the short run production function for the firm showing output as a function of labor. Go. Output is a function of labor. Start with the function. This is just the generic way of writing. That's what I wrote on the board. And then jump right into the numbers. So you could probably just jump right into the numbers. So this is really the specific functional form showing output as a function of K and L, right? That's really general, like just kind of verbally saying, hey, we got a production function that's a function of capital and labor. Hey, that's what it looks like more specifically. And then we're going to take that one more level and say in the short run, K is 3. And so substitute in a 3 into that K. So start writing that out first. So write an equation for the short run production function for the firm showing output as a function of labor. Right now it's a function of capital and labor. With capital being 3, you can get rid of that K. Yep. That's good. Q equals this, just like kind of taking off. Yeah, you need to be a little more careful with how you're laying out your equation. There you go. Now, that looks good. So at the end of the day, we want quantity as a function of labor only. We're able to do that because capital's fixed. Originally, we've got a generic formula, quantity as a function of capital and labor, some general function. Now we put a little more structure to it by having a functional form to it. Now bear in mind, this could take on some other crazy form, right? So this isn't like a magic formula that the world works around. This could have been plus KL plus K squared or something goofy like that, right? Who knows what the heck that thing looks like? That's kind of what we're saying at this stage. When we get down here, we're refining the functional form of how capital and labor work together to make quantity. All right, so you should get down to 19. Everybody get this part all right? 3 raised to the 0.25 power times 15, 19.74. Part B, calculate the total output produced per hour for L equals 0, 1, 2, 3, 4, and 5. So I'm going to do it, I'm going to do 0. And then we got 1 Taylor, or let's see, Adam. You're going to do 1, 2 Blake, 3 Jesse, 4 Taylor, 5. So that you all do a number. And then I want you to tell me your number. So at L equal 0, 1, 2, 3, 4, 5. Output equals. As soon as you get your answer, tell me what it is. I took 0 because I'm done. 0. 19.74. 33.20. 55.83. How much? 66.01 is what my thing says. So we'll just go to 2 decimal places. And 3. How do we do? Who's on it? Colby?
Just plugging it in.
Okay.
This is financial calculation.
Okay. Well, and you can take it, well, we'll figure out your calculator later if you want to. You were able to do the 0.75 or not? Okay, you'll have to get that down later. I can look at your calculator with you, but somebody else do 3? Maybe you can work links. How much? 45. And some change again, 45.01. You got it? Okay, cool. All right, so there's our schedule of numbers. Calculate the marginal product of labor for L equal 1 to L equal 5. Is it diminishing? So, yeah.
Okay, when you did that, did you take the L to the 0.75 and round that first and then multiply it by 19.74?
Well, ideally, I don't think there was any rounding, so just let it all play out, or is that what you did?
Well, I ended up the same answers as you.
Okay. Well, it's only off by a couple. That's not gonna, I'm not too worried about it. That's what the key said here, so. But usually, if you can take it so that whatever your answer is here times that, didn't round your decimal, it gave you exactly 45?
No, it was like
Oh.
44.997.
Oh, so you had it going that way. Well, maybe it was rounding, I don't know.
But then if you round it, you
Oh, I
get
got
45.
If you rounded the L, then you got
Yeah,
that?
round L
Oh, maybe
first.
they did round it first, okay. I didn't look at what they did here. But I'm also not gonna beat you up on .01, so. Okay, marginal product. Why don't we have the same people do the same ones here for marginal product? Anybody wondering how the heck you're gonna do that? You can actually go back to principles class. Just subtract them, yeah, because we've got all the data here, right? You've got all the information right here. So the marginal product of labor is the change in quantity from a change in a unit of labor, which labor is going up by 1 unit all the way, so it's just the difference between these numbers. So we got 19.74 here. What else? 13.46. Grab your numbers that you guys grabbed before. $10.18 for 6. 11.81 for 3. Okay. We've got 4. 10.2. Okay, let me call it that. So, is 8.2, yeah. Is it diminishing? Yes, right? So the numbers are getting smaller, the law of diminishing marginal product. Calculate the average product. The average product of labor is the quantity divided by the units of labor, no deltas. And we get 19.74. What else? Everybody do their number. $2.036. I think that's too low. 66 divided by 5. 13.96. $16.6 is 2. Yes. 3 is 15. Up. Okay, so some of this is a little bit of principles review, but we're kind of, the different thing that's not from principles class is generating it from a function, right? And coming back to some of the basics that we had here. All right, questions on that? But you got to know these basics here of average product. We're just taking the whole numbers, marginals. We're looking at the incremental changes. Right back to the basics. All right, flip it over. You guys got 6.2 on the other side, right? Suppose that the wage rate is $10 per hour and the rental rate's 25. Write an equation for the ISO cost for the firm. So ISO cost, put capital I guess we're writing an equation first, we're not even drawing a graph, I'm jumping to part B, but ultimately that's what we're gonna do. So write an equation for the ISO cost line.
What variable do you use for ISO cost?
For what? Which,
Like, in an equation.
okay, they've been using, C. If that's what you're wondering.
Yeah.
Okay. So we're basically calculating the total cost of production. So I think I might have used TC last time. So total cost. Okay, put what that's equal to. We're gonna start with cost of C is equal to that. Good, Colby, you started off with the right. That's a good stuff, a good way to start off the problem. All right. So it's the sum of what we're spending money on, looks very similar to our expenditure function from the our budget line from the utility function. So we got cost equal to the wage rate times the quantity of labor plus the rental rate times the what did we have here? $10.25. Okay. Draw a graph with labor on the horizontal axis and capital on the vertical, showing the ISO costs for 800. Indicate the horizontal and vertical intercepts. So part B, so this is part A. Part B, we're gonna let costs be $800. How are you guys tackling this? Let's talk about that before you jump into it. If you need to graph it, how are you tackling it? There's a couple different ways. Find the intercepts. Okay, yeah, I think that's a good way to go. That's probably the quickest way to go. And so how do you find the intercepts? Okay, so from the equation you can plug in 0, and then that'll end up solving that equation. Right, plug in 0 here, what does this equal? Or, I'd like to think of it as just, I got $800 to spend, what if I bought all labor? How much labor would it be? 800 divided by 10 gives me 80 units of labor. So find those endpoints is usually a good way to do it. As long as you know that the functions align. Otherwise, alternatively, you could solve for slope-intercept form with a line. Okay, what'd you get for your endpoints? How much?
32.
32 for capital? Okay. So 32 for capital and labor? 80. Alright, so slope intercept form, I did that up here. probably not the way I would have necessarily done it, but slope 800 divided by 32, or by 25 is 32. So the intercept's 32, the slope of the line is negative 10 over 25, which is the wage rate over the rental rate. So this was the ISO cost equation that we did last time in generic form. Alrighty, let's see, did we answer everything there? Suppose that the price of capital falls to 20. Show what happens to the ISO cost line of 800, including any changes to intercepts and slope. So, conceptually what happens? Rotates which way? Upward. So new, can I buy more labor with that change? No. How much, what's the new capital intercept? 40. All right. Questions on that? Okay, so let's see. Did I even give you guys 6.3? Alrighty. Yeah, I didn't give it to you. I want to do while I'm gone, I want you to have a production function and show the optimal quantities of labor and capital with some sort of production function of your choosing, and show how the firm is maximizing profits. I'll be back in 3 minutes and look at what you did. So incorporate an ISO quant onto that. Nope, I didn't want an equation, but I want more information than that. I'll come back to you. I'll come back to you. Show me graphically the optimal profit maximizing quantity for the ISO quant. You got nothing. we need to talk. So, for Wednesday, and tomorrow for that matter, how would you show the utility maximizing combination of kites and landmines? What would you do to show the consumer equilibrium of kites and landmines? Maybe it's lollipops. I don't want to bring in national defense into it here. Kites and lollipops. So, what would you need to do by adding in some indifference curves to show the optimal quantity of kites and lollipops? And Taylor's the only one that had something down, so let me pool the rest of you guys. What's going on at the optimal quantity of kites and lollipops? What is the utility maximizing condition?
Where the indifference curve and the product constraint intersect.
Good, okay. Intersect?
Well, meet, yes.
Meet. Be careful, because intersect can happen like if I have one coming down like this. They could be intersecting. So we want them tangent to each other, right? So draw it. Draw an indifference curve for kites and lollipops that's just tangent to that, let's just make it that outside budget constraint. Now, on the exam, how would I want you to show me that I know that you're showing the optimal quantity of kites and lollipops at that tangent point? What else would you need to add after you draw that? The quantities. So do it.
Would you just add, like quantity equal to,
Whatever you're, well, yeah, if you're drawing it general, you would just have utility equal to 1, 2, 3, 4, it doesn't matter, it's kind of arbitrary. But if a problem said utility level is 150, then you need to put probably 150. But along this indifference curve, all points along it are points of indifference for the consumer between kites and lollipops, right? And the optimal condition is where the marginal rate of substitution, the ratio of the marginal utilities for the indifference curve are equal to the slope of the budget constraint, which is the price ratio, the price of lollipops over the price of kites, right? So that is the optimal quantity of lollipops and kites that maximize utility. So now the only thing I'd want you to change for this problem is that we're not talking about an indifference curve, we're talking about an ISO cost line of 800. Along this curve, oh, I'm sorry, that is not the ISO cost line. This is the ISO quant line. The cost was the flat one we drew in the first place. So you can draw a quantity, and that quantity is going to be whatever it's going to be. I didn't give you, so this is just kind of a generic ISO quant line, now showing the optimal quantity of labor and capital that maximize profits ultimately for this. What we're really maximizing though is subject to a ISO cost line of $800. What is the maximum amount of output that's possible? Before, when capital was more expensive at $25, I couldn't make as much as I could before. So again, just making up numbers, if I was at 100 units there, I'm only at 80 units here maybe, whatever our production function would say. If we go back to our production function, we can actually calculate what that number is on the ISO quant. But there's a whole bunch of these. And so this problem, similar to the utility maximization problem, is what's the maximum amount of output I can make given the fact that I only have $800 to spend, right? So same thing, but now it's the company saying what's the maximum amount of stuff I can make. The shape of the contour, whether it's kind of flat or whether it's real angular, depends on for one thing, the substitutability of labor and capital in your production process. So the functional form of your production process determines how flat or steep or what direction these things head, if they kind of head this way. Similar to how for the consumer, we had preferences that did that. All right, so let's take a look at the next problem. Which is I didn't have these numbers here, the firm employing, the one that starts off the firm employing. If you guys want to write on there, it's 6.3. A firm is employing 100 workers at a wage of 15 and 50 units of capital at a rental rate of 30. At the firm's current input use, the marginal product of labor is 45 and the marginal product of capital is 60. Is the firm producing its current level of output at the minimum cost, or is there a way for the firm to do better? So now all we have is some data on the marginal productivity, similar to what we did here, right? So we got information on the marginal products of labor and capital. And the question is, at the optimal point, what needs to go on? And for this condition, the marginal rate of technical substitution between labor and capital is equal to the marginal product of labor over the marginal product of capital. That needs to be equal to the wage rate over the rental rate. Same thing we did for utility maximization. It was the ratio of the marginal utilities equal to the price ratio. Same concept, nothing different, but now you need to apply it to this problem. You've got those variables, so put them to work. You can do this kind of either way, but let me show you one other thing that could be useful. We can flip these around and think about the marginal product per dollar, which is similar to the marginal utility per dollar. So how productive is my labor force? Well, they can make 8 hamburgers per hour. Yeah, but how much do I have to pay them per hour? Well, what about the machinery that I got? Well, each machine can crank out 100 units per hour. Yeah, but how much do I got to pay them? So in each case, we're looking at the marginal productivity per dollar spent, which is the same equation, just rewritten a little differently. So we're equalizing the marginal product of labor and capital. Yes, it does.
Okay.
Yeah, I mean, you're on the right track. What you might do is, well, you didn't, let's see, is that what you, yeah, you did do that.
Yeah.
Okay, so 3's not, so you determined that it's not optimal.
Right.
And now, tell me what they can do to make themselves better is what the question asks. So good, yep, not optimal. Now, how can they make themselves better? What do they need to do to be more profitable, staying within their budget? Okay, so are these two things equal to each other? No. So put a don't equals. So there you've shown that that the two aren't equal to each other. Oh, you were on the wrong side? So what should it do? Most of you did this top one. Do this one next. So calculate the marginal product of labor divided by the wage. And the marginal product of capital divided by the rental rate. 3 and 2. Okay, which one's which?
The marginal product of labor divided by wage.
Okay. Rental rate is 2. Okay. So what is the interpretation of that? 2 what? 3 what? Okay. 2 rental rates per unit of capital. What was this number again for marginal product of capital? 60 units, 60 Qs, right? Divided by 15,
No, 30.
30. Yeah. $30, which means this is Q over dollars, right? That's why I like to use that little notation because it kind of helps you remember. I'm getting 2 units of production for every dollar I spend, with an additional unit of capital. With labor, I'm getting 3 units for every dollar I spend. What should I do to increase profits? And those two things not being equal is a problem. Right? So you guys got that part. What should I do? Without spending any more money. What does that signal to you? What does that signal to the entrepreneur to do? Okay, decrease to 3. Fire people. So we got 2 units. So at the margin, remember that you always got to go back to this economic way of thinking, the marginal thing. So like, if I was making a move tomorrow, what would if I needed to increase quantity, what would I do? Hire another unit of labor or another unit of capital? Another person, right? Because one person, for the same amount of money being spent, gets me 3 units made. A machine gets me 2 units made. So it'd be better to do the labor. Now, to get back to your, who said decreasing L, or decreasing, okay. Now, conceptually, if I hire another person and we move down the list on the marginal product of labor, what happens to the next person's marginal product of labor? It decreases, right? So the law of diminishing marginal product is going to have that happen. So that's going to start to happen already. But the point is, we're maxed out right now on our cost. They didn't give us costs, right, on this problem? So I'm going to put one. I don't think there was. But we did have the slope of this line.
We can figure it out. They give us the number of workers and the rate. So
Okay, right. So what's this? We do know the slope of this line. The slope is a negative what? Generically, it's always equal to what? What's on top, what's on bottom? Price of whatever's on the horizontal axis. Price of labor, which is the wage over the rental rate. Boom. The wage is how much? 15. Rental rate is 30. Got a slope of a half. Okay? So that's good. We are currently operating at a certain amount of labor and a certain amount of capital, which was what and what?
Or 50 capital.
50 capital and how much? 100 units of labor. So we're currently at that point A. At that point, this ain't going on. These two things aren't equal. So, spending the same amount of money, how could I be more profitable? What would I need to do? Same conclusion you just came up with, except now I'm going to constrain you to not spending another dime. What do we need more of? Labor. So we need to move this way along the ISO cost curve to a new point B. So what must have been true at point A? We don't have to draw this for the picture, but there was an ISO cost curve that was cutting through and looking like this. So we had an ISO quant that looks something like that. And spending the same amount of money we were before, we could produce more and not cost ourselves a dime. Same thing that's going on with utility that you guys need to know for tomorrow and Wednesday is that if the marginal rate of substitution, if these are in difference curves, at point A, the slope of this was how much? What was the slope here? 2. The slope of the ISO cost was a negative half. So the two slopes weren't equal to each other, telling you to move that way. Increase labor, decrease capital, reorganize your budget, reorganize your spending. Okay. So let's have a quick little review of some things that come to mind for the test.
I have a question.
Yes.
By changing that, if you decrease your amount of capital and increase your amount of labor, your marginal production rates would change, right?
Yes.
So
Your productivities are going to change. So this one's going to come up. This one's going to come down. They're going to meet in the middle at the optimal. Yes. And so that's what we're really doing. By reallocating, this one's not staying fixed. This one's actually converging up on each other. Okay, so let's do a quick list. Quick memorization list. I think it's always good to have demand and inverse demand. that whole concept of what's going on there. Supply and inverse supply. I mean, hopefully you guys got that down, but you should be able to go back and forth and what they mean and why we do them. We got the general concept that shifters apply to quantity, i.e. to the regular curve, and taxes and subsidies apply to prices. In other words, they apply to the inverse when we're doing it in equation form. So we should know areas for welfare analysis. Consumer surplus, producer surplus, government revenue. We got the utility max. I think you should be comfortable thinking about that graphically, as well as writing it out in terms of equations. Utility max, kind of graphically, is getting on the highest indifference curve. So indifference curves are going out, so we're going to make ourselves as happy as possible, subject to some sort of fixed budget constraint. We've got the other one that we talked briefly about, because I just want to tie these things together with similar to what we're doing here. We can think of the expenditure minimization problem, which graphically is minimizing my spending subject to a fixed amount of utility. For each of these problems, the utility maximizing condition is always the same. The marginal rate of substitution between goods X and Y is the marginal utility of X over the marginal utility of Y equals the price of X over the price of Y. And this is the slope of the budget line. And this is the slope of the indifference curve. Obviously, that's just a quick little bullet list. But I think these are things that you should pretty much have off the top of your head. Like, before you come in Wednesday for the test, you should say, I get that. I spent some time over the last 2 days, like, I get what he means by this. And if you don't, you need to ask some questions. You got problems. I already told you to work through the problems in the back of the chapters that are starred, that have the answers in the back. Yes?
If we work through, or I guess watch all the videos that you have on your YouTube channel, is that a good resource as well as far as what will be on the exam in total or not? Like, I mean, did you leave stuff out in the class that you don't have up yet? Or?
No, it's all on there.
So, okay.
Yep. I did that all on Friday even. So
That's fine.
the only thing that's not on there is what we did today, which is not on the test. So
I'm about halfway through the videos, so.
okay.